These are your instructions. In general, you just need to follow a PowerPoint. Please make sure the sound is turned up on your device so you can hear the narration. On some of the slides, there are instructions for you in the yellow boxes. And don't forget, if a slide asks you for homework, send it in via Show My Homework. And if a slide asks for Educate to be completed, don't forget to do it by the date given.
This lesson is all about momentum and changes in momentum. By the end of the lesson, you should be able to explain how a resultant force acting on an object results in a change of momentum and to use an equation to calculate the force. And you should be able to describe how safety features such as seatbelts reduce the dangers of changes in momentum. You should remember from previous lessons that we define momentum as the product of mass times velocity. Now, a key point here is that rapid changes in momentum can be extremely dangerous. During an event like a car crash, the momentum of passengers falls from a large amount to zero in less than a second. This is because they go from travelling at a large velocity to being stationary in a very short space of time. This in turn causes large forces on the passengers, which can be dangerous and lethal. Car manufacturers use crash tests like the ones in this picture to design safety features such as seatbelts. We can start by having a look at some of the maths involved. Now, if you remember, Newton's second law tells us that force equals mass times acceleration. We also know that we define acceleration as a change in velocity divided by time. Now, we're going to do a little bit of algebra to work out the force generated when an object changes its velocity. And to do that, what we're going to do is take this equation for acceleration equals change in velocity divided by time and substitute it back into this. So remove this term, acceleration, and replace it with this. If we do that, we get this. Force equals the mass times change in velocity divided by time. And we often write this like this. Force equals m delta v divided by delta t. So the force equals a mass times the change in velocity divided by the change in time. Or another way of phrasing it is force equals the change in momentum divided by the time taken for that change in momentum. Now, you don't have to learn this equation because it is given to you on the equation sheet, but you do have to know how to apply it. So let's have a look at a worked example. A man with a mass of 100 kilograms is a passenger in a car. The car is traveling at 30 meters per second. The car comes to a stop in 1 second. Calculate the force acting on the man. So the force is generated by the change in momentum. And this is the equation we're going to use. Force equals the change in momentum divided by the time. If we substitute in our figures, the man weighs 1,000 kilos and the speed is 30 meters per second divided by the time is 1 second. So that gives us a force of 3,000 newtons. Now that's a huge amount of force. Rapid changes in momentum do lead to huge forces being applied, and to people these can be fatal. We can reduce the danger if we make the change in momentum happen over a longer time, effectively if we slow down the collision. So let's have a look at the same collision, but if we this time, instead of it occurring in a time of 1 second, let's see if we can slow it down to 2 seconds. If we do the calculation again, but substitute in a time of 2 seconds instead of 1 second, you see that the force comes down to 1,500 newtons. By doubling the time it takes to stop the person moving, we have halved the force that is generated on him. Now, this idea of reducing the force that is generated by slowing down a collision, increasing the time over which the collision takes place, is used in lots of safety devices. Stop the recording here and see if you can think of any. Here are some for you to consider. This is a gymnastics or athletics crash mat. It's a bicycle helmet. This is absorbent flooring for an outdoor playground. Airbags. Seat belts. Now all of these work by slowing down the collision. So from the moment the collision stops, it slows it down so that it takes place over a longer time than it would if you didn't have that device there with you. And that reduces the force generated. And that increases the chances of you surviving and minimizes the damage done to you because the force generated is less. Okay, for you to try. And here's another question for you to try. And your final task from this week is to send me a picture of your work from this lesson for Friday. Thank you.